Hello and welcome back to graphs of rational functions in the form f of x equals ax plus b over cx plus d, or linear over linear. And this is part 2, where we're going to look at some thinking questions. And as examples, I brought 2 questions, examples 4 and 5. And let's get started with example 4. Now, first, when I solve such problems, I read the problem without the intention of solving it right away. I just want to get a general idea what it is about. And it says that we have to find a rational function with a vertical asymptote at 3, a horizontal asymptote at 1, y-intercept at -2, and it decreases in the interval from -infinity to 3 and 3 to infinity. So it's an overall decreasing function. So I read it a second time, and this time I will also plot the information down. So according to this problem, we know that the function has a vertical asymptote at x equals 3, so I'll write this down. So there is a vertical asymptote at x equals 3. And then there is a horizontal asymptote at y equals 1. And I'll write this down as well. So there goes a horizontal asymptote, y equals 1. And it has a y-intercept at -2, so y-intercept is -2. And it's an overall decreasing function from -infinity to 3 and 3 to infinity. I'll write this down as well. And I will pay closer attention to the fact that this function is decreasing almost all the time except at 3, where it has a break. And the break is exactly at 3, and it makes sense because at 3 we have a vertical asymptote. So -infinity 3 joined by 3 to infinity. So I'll start with the vertical asymptote. So whenever we are solving such problems or answering such questions, we need to interpret the information, or we need to learn how to read the information differently. So a vertical asymptote to me means that this function must have had some restriction in the domain. And the restriction must have been x different than 3. And remember that restrictions are found by making the denominator 0. So by bringing 3 to the other side, we're going to say that we must have made x minus 3 different than 0. And that tells me again that x minus 3 must have been the denominator. So this function, the rational function, has a denominator of x minus 3. The next information given is that the horizontal asymptote is at y equals 1. Remember that we're finding a function in the form y equals ax plus b over cx plus d. And horizontal asymptotes, we said, are found by finding the ratio of the leading coefficient. So it seems that the ratio of the leading coefficient a over c here is equal to 1. Now, knowing that the denominator in our case is x minus 3. Here we go here. So we have ax plus b. We don't know what numerator is, but we do know that denominator is x minus 3. And given that the horizontal asymptote is at 1, tells us that the ratio a over leading coefficient of the denominator, which is 1, equals 1, tells us that the coefficient a must have been 1. So therefore, we're going to say that the numerator is 1x plus some number b. So far, we have brought the equation to the form y equals x plus b over x minus 3. So we have one missing piece in this function, which is the constant term b. And for this, we're going to ask for help the y-intercept. If the y-intercept is -2, it means that at x equals 0, the value of y is -2, which means that we are given a point on the function. And what we're going to do is substitute x by 0. And we'll know that the function will give a value of -2 here. So this means that negative 2 equals b over negative 3. And again, b equals 6. Simple equation to solve. So we're going to say that the function is y equals, so far, x plus 6 over x minus 3. Now, we're also given the end behavior of the function. Why is that? Remember that even though we are told that the ratio of the leading coefficient is going to be, equal to the horizontal asymptote, it could have been also that the coefficient of x could have been negative here, and this one positive, and this coefficient negative. So there are two possibilities, as a matter of fact. So one possibility that satisfies all the conditions is the one that we just wrote down. But another possibility can be negative x plus the coefficient b over negative x plus 3. And in this case, actually, we would have had a negative x minus 6 here, right? So in this case, we still have the same b value, right? And we have negative over a negative, which is equal to 1. So how can we confirm which one is our equation? It's the end behavior. So if I were to sketch the graph of this function with the information I have in hand, I would say that the vertical asymptote is at 3 somewhere. The horizontal asymptote is at 1. And if I knew that the graph will be decreasing at all times, sorry, here, I want to bring this a little bit further down so that it meets exactly 1. All right, here we go. So this function will be decreasing all the time, which means that the function is going this way around. Okay, so if the function is going this way around, that means that for x values bigger than 3, the y values must be positive. And it seems that in our case, the function will be going this way. We have a y-intercept at negative 2. So it must be something like this, right? So, which means that the first equation is the one that satisfies the condition, okay? So, moving on to the next example, we are given the function f of x equals 7x minus m divided by 2 minus nx. So notice that here we're missing some coefficients or constant terms. So we're missing m and n. We have to find the values of m and n if we're given that the asymptote, the vertical asymptote, is at x equals 6. And the x-intercept is at 5. So the first thing I want to do is rearrange the terms in this function, because I want to start off with the x terms. And that means that negative nx must be first and then plus 2. So now I can see where the vertical asymptotes come. The asymptote will come from. So vertical asymptote comes from making the denominator equal to 0. Or we'll say that denominator has to be different than 0, which means that x must be negative 2 divided by negative n, or x equals 2 over n. Now, since the vertical asymptote is at 6, that means that 2 over n must be 6, right? Because the vertical asymptote is 6, which means that these two things will be equal. So By equating 2 over n by 6, we're going to get n equal to 2 over 6 or 1 over 3. So we'll say that the value of n is 1/3. That means that the function has been brought to the form 7x minus m divided by negative 1 over 3, because the negative was already there, right? Negative positive 1/3 x plus 2. So the next thing that we want to do is find the coefficient m. And for this, we're going to use the x-intercept, which is at 5. So x-intercept being 5 tells us that the value y will be 0 at x equals 5. So 0 equals 7x minus m. Negative 7x equals negative m, which gives m equal to negative 7 times 5. So the value of m is negative 35. So the equation of this function will be y equals 7x minus negative 35, positive 35, sorry, divided by 1/3 x plus 2. So in a simpler form, we're going to write this as 7x minus 35 over, and we can also factorize the 1 over 3x, or write negative 1 over 3x plus 2 as negative x plus 6. Even better, this would be y equals 7x minus 35. Bring the negative to the front. Factor it from the denominator, x minus 6. And voila, we got the equation of the function. So this is it for this lesson. I hope that this made sense. And again, thank you for choosing to learn from me. Bye for now.